Continuing with chapter 2, we looked in 2.1a. We took a look at all of this stuff. We didn't really use this, but we did use these 6 trig functions up here. Okay, so we did that in 2.1a. In part B here, now we're going to take a look. 2.1b, we're going to use, you could still use this up here, but more importantly, what we're going to be using is the stuff here on the back of this worksheet with these trig identities. So we're going to go through and start using the majority of these. Okay, so that's going to be 2.1b when we take a look at this. It's also, as we continue into 2.2, we're going to start using the rest of the Pythagorean identities down here as well. But the majority of what we're going to do in 2.1b is going to be based on the stuff, questions or problems 1 through 4 here. So the topic of this is simplifying trig expressions. So there's a couple steps that you want to do in that. The first one is that you're going to put whatever you have, whatever the problem is, in terms of sines and cosines. Now you don't have to do that. That's not a required thing. But you're trying to simplify it, and so simplifying a tangent is by putting it into sines and cosines. Okay, and that's going to be the first step that you're going to be trying to do. The second thing is that once you do that, if there's anything that's on top or bottom of a fraction, you're going to try to cancel it. If there's fractions that you can add together, try to add them. If you can subtract them, subtract them. If you can do some substitution, plug in a different type of equation that means the same thing, go ahead and do that. And then finally, we're going to factor. Basically, what's going to happen is that you're going to manipulate the problem until you get the answer. Now, here's the fun part about this. As a math teacher, to me, this is a great time because you're trying to take this abstract idea and manipulate it using a bunch of math to put it together and come back with an answer that is given to you. As a student, the fact that you're manipulating this and doing, bringing in all of these other math things, bringing in all these other equations, all these other expressions, you're trying to manipulate this, it can become frustrating. Okay, and so when I say manipulate it until you get the answer, I will give you an answer when we're taking the test because I don't want you to be kind of floundering out while we have a timed test. But on the homework, I'm not going to give you the answer in the beginning here. So yes, if you look in the back of the book, there could be an answer there. But chances are, if you were to take a look in the back of the book, it would say this. Answers will vary. Okay, and so also a reason that I'm going to put the answer on the test is that I want you not only to have that goal, but I want us all to be getting to the same place. Okay, because answers are going to vary, and so the way that you go through and solve these it is going to be a little bit different for each of us, which is a nice thing, and kind of a scary thing at the same time. So let's take a look. This is number 15 in the homework here. We're looking at secant x times cosine x. Well, again, step 1 is turn things into sines and cosines. So secant x, that's 1 over cosine. Cosine is already cosine. And well, then step 2, after I change them, is I want to do some multiplying, adding, subtracting, whatever it says to do. Well, this is a multiplication problem, so multiplying fractions together, I get cosine x on top and cosine x on the bottom. Those two things divided by each other give us an answer of 1. Okay? And that's going to be the answer. You will, again, look in the back of the book. It's going to say answers will vary, but ultimately that's the most simplified version. I can't do anything else with a 1. Okay? That's going to be the most simplified version. So it comes to a point where we start looking for what is the definition of simplified. Okay? And so keep going as far as you can until you think that you can't go any farther. Let's take a look here at another one. Okay, so here's number 23 from the book. Bear with me a little bit as we go through and explore this one using the sines and cosines method, and then I'm going to show you a faster method afterwards that will allow you to start exploring these a little bit more in a better way rather than just following a process, actually thinking about what you have in the problem. All right, so if you're following the process, you're going to say, well, this is 1 over cosine to the 4th x. And secant is 1 over cosine. So if I take secant to the 4th, I get 1 over cosine to the 4th. So tangent is secant sine over cosine. So if I do tangent to the 4th, I get sine to the 4th and cosine to the 4th. Okay? The 4th power just doesn't have a ton to do with the sine cosine part of it. It still factors out that way. So then step 2 is to do any adding or subtracting. Well, they have the same denominator, so I can add or subtract those. In this case, subtract, and put them over the same denominator. Okay? No problem. At this point, you might say, well, I think this might be as far as I possibly could go. Okay? And that's why I'm going to start giving you the answer. In the book, it also gives you the answer, gives you options on this set of problems to give you one of those answers. And this is not one of the answers. And so at that point, you know you have to keep going. If you keep going with this, the only thing that you can do is you can factor the top. So there's no adding or subtracting left that you can do. There's only factoring that's left. So on top, I can factor this binomial as a difference of squares. 1 times 1 gives me 1. Sine squared x times sine squared x gives me sine to the 4th x. 1's a minus and 1's a plus, so that when I use the distributive property, typically known as FOIL, when I use FOIL here, then the middle terms are going to cancel out. This is a difference of squares. We talked about difference of squares when we were factoring. Underneath, I've got cosine to the 4th x still. Well, at this point again, I followed step 1, I followed step 2, where I did some subtracting, I did some factoring. The next thing says substitution. Well, if I go back to what we're looking at here, there's substitution that I can do here. I have in my Pythagorean problems here, I have that 1 minus sine squared x is actually equal to cosine squared x. This sheet is going to become invaluable for you. If you have things that are squared, this kind of leads us into the idea of verifying identities and doing some other type factoring type things. And so this is the first problem that kind of leads us into that. And so when I look at this, I've got cosine squared x equals 1 minus sine squared x. So I go back to my problem here, and I had 1 minus sine squared x right here. So I can substitute, that was one of the options, cosine squared x. And I have 1 plus sine squared x. 1 plus sine squared x does not equal cosine squared. 1 minus sine squared does. And then that's over cosine to the 4th x. Well, continuing again, this does not match what the book has for options for me, so I need to keep going. And cosine squared x would be just like x squared, and cosine to the 4th x would be just like x to the 4th. Okay, they're a squared on top and a 4th on the bottom. Well, we did exponent rules with these. I have 2 x's on top and 4 on the bottom, so I'm left with a 1 on top because 2 of these are going to cancel with 2 of these and leave me with x squared in the bottom. So this is going to cancel, and it's going to leave me with a cosine squared in the bottom. So I've got 1 plus sine squared x on top over cosine squared x. Again, not an option, but I've got an addition problem here that I can separate this so that it's 1 over cosine squared x plus sine squared x, and I'm losing some of you already as I'm going through this, and that's why we're going to look for a shorter method. 1 over cosine squared x is secant. Sine squared over cosine squared is tangent squared. That is an option in the book. And so I know now that I have that option in the book, that's the correct answer. I can't go any farther than that. Although it doesn't look any more simplified than probably what we started with, it is. These have squares, the other one has fourths, it had a minus, so it was a difference of squares, etc. And so that's the process that you're going to go through. Now let's take a look. Let's take that same exact problem and look at it in a little bit different way. Instead of taking and following just a rote memorization type going through and changing sines and cosines, we can look at this in a more mathematical way. I can see that I have things that are to the fourth power and a minus in between. So I could try to see if I can factor this first. And I can, because secant squared x times secant squared x is equal to secant to the fourth. Just like x squared times x squared is x to the fourth. Tangent squared x times tangent squared x is equal to tangent to the fourth x. It's a difference of squares, so that the middle portion is going to cancel out when I do the distributive property, also known as FOIL. And so I end up with a difference of squares here. Okay, now I have some squareds. Well, that again brings me back to this original sheet that we started with, looking for a secant squared and a tangent squared. Well, if I look at the second one, I've got this, that secant squared x minus tangent squared x is actually equal to 1. And so when I go back here, this portion is actually equal to 1. So I get secant squared x plus tangent squared x. That's one of the options in my book. Okay, secant squared x plus tangent squared x. 1 times that doesn't really do anything. Okay, you can see this whole problem right here. If I think about it mathematically instead of following a rote memorization type situation, then I can get to that point without having to do a lot more work. Okay, so that's what needs to start happening here. And the only way that you can get that is by exploring, trying things and goofing up, and then starting over and trying again. Okay, and there will come a point where you get frustrated with this, especially if you're trying to do a problem and you get stuck and you can't get the answer. Do not sit and work on it forever. There's no reason to sit and be frustrated about it. Bring that back in so that we can take a look at it. We can either take a look at it as a class, or we can take a look at it individually, and we can try to work through these problems. Okay? Do not sit and get frustrated with them. If you get stuck at a point on a problem, put it aside, go to another problem, go through, try the next problem. If you get the next problem, come back to the one that you got stuck on, and then try it out again. Okay, sometimes it just really takes, in a learning process or working through math problems, it really takes you just a second, step aside, come back, and maybe you'll have a different idea of how to approach it. Okay, so you saw 2 ways to approach this problem. One is a longer process, one is a shorter one, but ultimately they get you to the same exact place. Okay, that's the beauty of math, is that you don't have to do the same thing that your neighbor does in order to get the same exact answer. Okay, and so make sure that you're going through these problems, giving them a shot, trying to do each one of them. This one kind of incorporated everything if we did it the initial way. So here's your assignment, page 227, 15 through 36. I want you to go through, try some of them. Some of them are faster than others. Okay, some of them take a little bit of time. Some of them you're going to get stuck on. When you get stuck on it, take a break, do another one, come back to it, go have dinner, come back to it, go play video games, come back to it. All right, do whatever you need so that you can actually get this process and take a look at it. I will post a second option for you as far as some videos that are done by somebody else, so that you can see their thought process that goes through it. Because sometimes I take a simplistic view just because I'm used to looking for these. Okay, but I'll post another video that is kind of more of along the lines of how a student might be looking through these. And if you have questions, bring them to class. Good luck.